The concept of time travel is something that has fascinated humans for centuries. From the first rudimentary time machines in fiction to the modern-day speculations of scientists, we have always been curious about the possibility of traveling through time. But what if we could actually do it? What would happen if someone were to build a time machine and travel to the past or the future? Let's find out. This concept has been explored in science fiction for many years and has captured the imagination of people all over the world. According to Einstein's theory of relativity, time is relative and can be affected by factors such as gravity and velocity. This means that time can pass differently for observers who are in different circumstances. For example, time would appear to pass more slowly for someone who is traveling at a high speed than for someone who is standing still. One way to achieve this would be to travel at a speed close to the speed of light, which is theoretically possible but currently beyond our technological capabilities. Another method would be to use a black hole, which can warp spacetime in such a way that time moves backwards. However, this would require coming extremely close to a black hole, which is also currently beyond our technological capabilities. Additionally, there are theoretical concerns regarding the stability of a time traveler who emerges from a black hole, as the intense gravitational forces and radiation could potentially damage the ship or its occupants. Despite these challenges, the possibility of time travel to the past continues to fascinate scientists and science fiction enthusiasts alike. Some theories even suggest that time travel to the past may be possible by creating a wormhole, a hypothetical tunnel-like structure that connects 2 points in spacetime. However, these are currently just theories and there is no evidence that time travel to the past is actually possible. Time travel to the future. Unlike time travel to the past, which remains purely hypothetical, time travel to the future is theoretically possible and has been proven by Einstein's theory of relativity. As mentioned earlier, time is relative and can be affected by gravity and velocity. This means that time would pass more quickly for someone who is experiencing a strong gravitational force than for someone who is in a weaker gravitational field. By traveling to a place with a stronger gravitational field, one could effectively travel to the future. This is known as gravitational time dilation. One way to achieve this would be to travel to a planet with a stronger gravitational pull than Earth. However, we haven't discovered any such planets near us. Another option would be to build a space station in orbit around Earth, where the gravitational pull is weaker than on the surface. Although this is currently beyond our technological capabilities, it is theoretically possible. Additionally, by remaining in orbit for extended periods, one could significantly increase the amount of time dilation experienced, effectively traveling to the future. This concept has been used in science fiction stories such as Interstellar, where the characters use a wormhole to travel to a planet with a strong gravitational field in order to travel to the future. It's important to note that while time would pass more slowly for the astronauts on the planet, time would continue to pass normally on Earth. This means that if someone were to travel to the future using gravitational time dilation, they would return to a world that had moved on without them. The potential implications of this form of time travel are vast and have been explored in detail in science fiction literature and film. The Grandfather Paradox. The Grandfather Paradox is a thought experiment in philosophy and science fiction that illustrates some of the logical issues with time travel to the past. The scenario typically involves someone traveling back in time and accidentally killing their own grandfather before their parent was conceived. This creates a paradox because if the grandfather dies before becoming a grandfather, then the time traveler's parent would never exist and neither would they. This presents a number of logical issues and has led to much discussion and debate regarding the possibility of time travel to the past. One way to resolve the grandfather paradox is to assume that time travel to the past is impossible. This is the most straightforward solution, as it avoids the need to reconcile the paradox in any way. Another approach is to propose various mechanisms that prevent the paradox from occurring in practice. For example, one could argue that the time traveler would not be able to kill their grandfather because their own existence depends on their grandfather living long enough to become a grandfather. This suggests that there may be some kind of natural law or physical constraint that prevents this outcome. However, this approach raises questions about how such a law or constraint would work and why it would apply only to time travelers. A third approach is to accept the apparent contradiction and explore its implications. This approach often involves considering the possibility of multiple timelines or universes, where the actions of the time traveler create a new timeline or universe in which the paradox is resolved. For example, in one timeline, the time traveler may kill their grandfather, leading to the creation of a new timeline in which the time traveler's parent was never conceived. In this scenario, the time traveler would essentially cease to exist in the original timeline, but would continue to exist in the new timeline. This approach raises questions about the nature of identity and the possibility of creating multiple timelines or universes. Ultimately, the question of how to resolve the grandfather paradox remains an open one. There is no consensus among philosophers or scientists, and the debate continues to this day. The bootstrap paradox. The bootstrap paradox is another thought experiment related to time travel that involves an object or piece of information traveling back in time and influencing its own creation. This creates a closed loop that is difficult to reconcile with our understanding of causality. Imagine, for example, a person traveling back in time and leaving a book behind that eventually becomes a classic that inspires the time traveler to write it in the first place. This scenario raises questions about the origin of the book and the role of the time traveler in its creation. Did the book always exist, or did the time traveler create it out of nothing? How does the time traveler know what to write in the book if they haven't read it yet? These questions have led to much discussion and debate regarding the implications of the bootstrap paradox for our understanding of time and causality. One way to resolve the bootstrap paradox is to assume that it is logically impossible for an object or piece of information to travel back in time and influence its own creation. This approach is similar to the grandfather paradox resolution that assumes time travel to the past is impossible. Another approach is to propose various mechanisms that prevent the bootstrap paradox from occurring in practice. This principle states that information cannot be destroyed or created, only transformed. However, this approach raises questions about the nature of information and how it is conserved in a closed system. Ultimately, the question of how to resolve the bootstrap paradox remains an open one. There is no consensus among philosophers or scientists, and the debate continues to this day. Theories of retrocausation. Retrocausation refers to a hypothetical form of causality in which an effect occurs before its cause. This concept has been explored in various ways throughout history, including in the philosophy of time travel. One example of retrocausation is the Novikov self-consistency principle, which proposes that any changes made by a time traveler to the past are already taken into account in the future that the time traveler came from. This means that the time traveler cannot change anything in the past that would alter the future. Another example of retrocausation is the presentism theory of time, which argues that only the present moment is real and that the past and future exist only in potentiality. While these theories are speculative and not widely accepted, they offer interesting perspectives on the relationship between cause and effect and the possibility of time travel to the past. In conclusion, the concept of time travel continues to fascinate and intrigue us. While time travel to the future is theoretically possible, time travel to the past remains an impossibility according to our current understanding of physics. The grandfather and bootstrap paradoxes highlight some of the logical issues involved in time travel to the past and have led to much discussion and debate regarding the possibility of retrocausation. Whether or not time travel will ever be possible remains an open question, but the concept continues to capture our imaginations and inspire scientific inquiry. Thank you for watching this video. If you enjoyed it, please like and share it with your friends. Don't forget to subscribe for more videos like this. We'll see you next time.